I hope you all are doing great. Today's topic is limit. So let us understand what is the meaning of limit as well as definition. Fx, when limit extends to a, this is a presentation. This LIM is a short form of limit. LIMIT. So limit when x approaches to a is what? So we will understand this concept with the help of one example. Example is fx x square minus 1 over x minus 1. Okay, but since x minus 1 is denominator, so x cannot be 1, right? If you put x equals 1, then 1 minus 1 is what? 0. Then something over 0 is not defined. That's why x cannot be 1. So this is given to us. Fx equals x square minus 1 over x minus 1, where x cannot be 1. You cannot substitute x directly to 1. By the way, x it cannot take as 1. But what would be the value of this fx when x approaches to 1? There is a difference between x equal to 1 and exactly 1. Here x cannot be 1. I mean x you cannot put equal to 1. But x can be left side of 1 or right side of 1. I mean it will approach to 1. So when fx will approach to 1, I mean in the term of limit, then what would be the value? So this is x square minus 1 over x minus 1, limit x tends to 1. This is tends. T-E-N-D-S, tends. X tends to 1, it means x is approaching to 1. Then what would be value of this expression? So let us understand this with the help of this presentation where I have drawn this table. So I will explain what this table is all about. Now x is tending to 1. It's not 1, tending to 1. It means x can be 0.999 or it can be 0.9999. It can be 0.99999, but it cannot be 1, right? So just left of 1. For example, this is real number line, this is 1. So x is here or here, it is approaching to 1, this side, this is 1, approaching to 1 from left to right. Okay, not exactly 1, it's approaching to 1. Okay, now 1, we cannot put 1, but we can put 1.00001. 1.0001 is what? Just greater than 1. So just greater than 1 means this side. So now it is approaching from right to left, this side. Okay, 1.00001 and again 1.001. This is also, this value is greater than this, I mean this side. Okay, it will be here. So x can be all these, then accordingly what will be y? So when we put x equals 0.999 here, then it will be 0.999 whole square minus 1 over 0.999 minus 1. You will calculate, you will get this using calculator. No need to calculate manually, you have to use calculator. Now again you can put this value over here, then 0.9999 whole square minus 1 over the same value, you will get this one. If you put this value over here, you will get this. If you put this value over, you will get this. Okay, now let us understand all these values. When we are substituting 0.999, then we are getting 1.999. Okay, if I try to draw approximate graph by understanding this concept, then what I am getting, this is x, this is y. So for example, if this is 1, so this side it will approach from left to right, it will approach from right to left. Okay, then if we are substituting 0.999, we got 1.999. okay, and 1.999 is approximately 2. Now again 1.9999, this is also just less than 2. And what is this? This is 2.00001. This is just greater than 2, not exactly 2, just greater than 2. This is 2.0001. This is also just greater than 2. So what I am getting, when I am coming to 1 from left to right or right to left, then my values is approaching to what? It is approaching to 2. So when I am coming to 1, then it is approaching to 2. Okay, so answer would be limiting value of this at x equals 1 is 2. Okay, so my answer for this question, I mean limit when x tends to 1, x square minus 1 over x minus 1 is plus 2. Why plus 2? Because when we are approaching to 1, from left side also we are reaching to 2, and from right side also we are reaching to 2, approximately 2. So this is limiting value. Again I am telling you, this plus 2 is not exact value of this when x is 1. When x will approach to 1 in this, then this expression will approach to 2, not exactly 2. So this is limiting value. Okay, so I hope you understood. Now let us understand again this concept with the help of another method, by not substituting this one, by some calculation. Okay, come to this point. This is limit x tends to 1. Now if you observe, then this is x square minus 1. You can write it 1 square. So it will be x square minus 1 square is like a square minus b square, and a square minus b square equals, you can write a minus b times a plus b. Accordingly, you can write x minus 1 times x plus 1 over x minus 1. Okay, now x minus 1 and x minus 1 got cancelled. Now you got limit x tends to 1 in x plus 1, and here you can put, x will approach to 1. When x will approach to 1, then here you can write 1. Now it is 1 plus 1 is 2. Okay, then when x will approach to 1, then this expression will approach to 2. Again, this is not exact value, this is limiting value. Okay, now again we have to understand this with the help of graph. So I am going to draw this graph, this one. Limit x tends to 1 in x plus 1, then what would be value? So this is x plus 1, so y equals to x plus 1 graph we need to find. Y equals x plus 1. Y equals x plus 1 graph we need to find. At x equals 0, if you put x equals 0 over here, then 0, then we will get 1. And when you put x equals minus 1, then it will be 0, like this. So we got 2 points, you can draw this graph. Okay, so this is a graph of y equal to x plus 1. But we need to find limiting value on this graph when x will approach to 1. So for example, this is 1 here, but this x will approach to 1. X cannot be 1. So x cannot be 1, then this value you cannot have. You have to fill with open circle, this one. You cannot fill this circle, because when you cannot put x equal to 1, then how can you get value of expression when x is 1? So at x equal to 1, this will be open. Okay, function is not defined over here. But what about when x is approaching to 1, when this side and this side, when x is approaching to 1, then 1 plus 1 is 2. So this is 2. Okay, so from this side we got 2, even from this side we also got 2. Okay, now we need to understand left side and right side. So we have a special name for left side and right side. So this left side value we got even 2, and right side value also we got 2, and left side value is called left hand limit, and right side value is called right hand limit. So when limit will exist, then left hand side and right hand side limits must be same. So in this expression, left hand side is also 2, right hand side is also 2. So at x equal to 1, we can say limit will exist, and what would be the value of that limit? Value of 2. So I hope you understood this concept, how you will find limit. Now we are going to learn this one. For existence of limit, left hand limit must be equal to right hand limit. Means LHL left hand limit, RHL right hand limit. there is another way also to present. F of x limit x tends to a negative equals f of x limit x tends to a positive. So we will understand what is the meaning of a negative. A negative means just left of a, and a positive means just right of a. So it means 2 negative means 1.9999 like that, just left of 2. 2 positive means just greater than 2, like 2.00001. But 2 negative cannot be minus 2. You have to understand this. 2 negative cannot be minus 2. This 2 negative, 2 positive is the presentation. How to write 1.999? Just left of a you want to write. Then a negative, just right of a you want to write a positive. So f of x when x is just left of a, f of x when x just right of a, then right hand limit, then you will get left hand limit. So when this condition is valid, then only you will say the limit will exist. If this is valid, then limit will exist. Okay? What is the meaning? Let us understand again with the help of graph. So we have this function. This will be any function which I will say y equals fx. Okay? This is y equals fx. Now I am considering this point x equals a over here, right? But I am not going to find exact value of fx when x is a. I am going to find limiting value of fx when x is a. Then how? Let us understand. I am going to consider this gap is h and this gap is also h. Okay? So this is a, from here to here this is a, and this gap is h. It means this point I can write a minus h. Okay? And this is a, then this gap is h, so I can write this point as a plus h. Then this coordinate, if x is a, then this coordinate would be f of a. Then this coordinate would be, when x is a, then put x is a over here, then y is f of a. So this is f of a comma f of a you got. Now when you put x is a minus h for this point, x is a minus h, then what is f of x? F of a minus h you will get, f of a minus h you will get. Now again at this place, when x is a plus h, then f of a plus h you will get. Now, but this h which I have presented over here, it looks so wide gap, right? But actually h tends to 0, right? H is a gap, so h will be tends to 0. So it would be 0 positive. 0 positive means h will have some gap. Gap cannot be in negative form, right? 0 negative means left of 0, and left of 0 will be negative. So gap cannot be 0 negative. So h tends to 0 positive. But apparently we write h tends to 0 only. Okay? We write h tends to 0 only. But what is the meaning? H tends to 0 means h tends to 0 positive. By the way, when limit will exist, then this left hand limit, when x is a minus h, then this is your limit. Okay? When x is a plus h, then this is your limit. Then these two limits must be same. So we have to put condition. I can erase this. So first I will write left left hand limit when left hand limit of x equals a is so first we can write f of x limit x tends to a negative. This is my presentation. This is same thing. F of x limit x tends to a negative. So what is that? This is f of a minus h. So I will write f of a minus h. Now right hand limit of x equals a is right hand limit. So right hand limit is this. That would be f of x limit x tends to a positive. Okay? And a positive means this one. And what is that? F of a plus h. So I will write f of a plus h. Okay? So it was the condition. Now f of x limit x tends to a negative. What is that? F of a minus h. But we have to put condition of h also. What was h? H was tends to 0. So I have to write limit h tends to 0 over here as well as limit h tends to 0 over here. So now we are going to learn left hand limit equals right hand limit. This is a condition. Then left hand limit we have learned right now, f of a minus h limit h tends to 0, which is here. Right hand limit which we have learned, f of a plus h limit h tends to 0, which is here. So this is a condition. So we can present limit question by this way, fx x tends to a negative or a positive, or by this way. Sometimes it is depending on the question. Which one you have to use, whether this or that. So let us understand this concept with the help of. Now let us understand this example. Evaluate left hand limit and right hand limit of function. Function is x minus 4 mod over x minus 4, where x cannot be 4, and function is 0 when x is 4. Then evaluate limit at x equals 4 and also check limit will exist at x equals 4 or not. See, what is the question? Over here, you need to find left hand limit and right hand limit separately. When left hand limit and right hand limit will be same, then you will say, yeah, limit will exist. If left hand limit and right hand limit are different, then you will say limit won't exist. So, let us understand. Answer is fx equals, that is okay, some condition is given, x cannot be 4. So x minus 4, when first condition x greater than 4, right? X cannot be 4, so x can be greater than 4 and less than 4, right? So when x is greater than 4, then it will open with positive sign. You know about modulus concept, modulus properties. Or you can say x greater than 4, I mean 4.1 you can take, and 4.1 minus 4, it comes positive, so it will open with positive sign. So here it would be x minus 4, and in denominator it is x minus 4, so no need to worry about it. Now x less than 4, in this concept, x greater than 4 we have taken one condition. Now x less than 4, x less than 4 means 3.9 for example I am considering, then 3.9 minus 4. So 3.9 minus 4, it comes negative output. So it means we have to put one extra negative. So it will open with negative sign. Then this is x minus 4 over x minus 4, right? And this is x equals 4. So at x equals 4, we have 0 value. For finding limit, we are not required x equals 4. For finding limit, we are required these two. By the way, this one, fx, we got x minus 4 over x minus 4, this is plus 1 when x greater than 4. X minus 4 cancel, we got minus 1 when x less than 4 and 0 when x equals 4, right? So we got this function. So first I will try to draw a graph, and from the graph we will understand. So this is 4, it is changing about 4, so this is 4 and this one is 1, this one is minus 1, right? When x is greater than 4, then it is not 1. It is, try to understand, when x is greater than 4, then it is plus 1. But at exactly 4, this is not exactly 4. At x equals 4, it is not there. This is x greater than 4. So when x is just greater than 4, then we got always 1. Why have I put this open circle? Did you understand? Because of 4. Here you cannot take 4. You have to take greater than 4. So that's why you have to put 1 over. What we have learned, when x greater than 4, it would be plus 1 always. So it would be constant graph. Okay? When x is less than 4, so less than 4, then minus 1. Not exactly 4, this is just less than 4. So for all values of x which are smaller than 4, you will get minus 1. So this is minus 1. Again, constant graph, right? By the way, when x equals 4, then what you will get? When x is exactly 4, then you will get 0. So when x is 4, then you will get 0. So you got this point. By the way, so this is a graph of this function fx, right? Now the question was evaluate limits. So orally we can learn from here. When you will take x just greater than 4, you are getting plus 1. So right hand limit is plus 1. When you will take value smaller than 4, then you are getting minus 1. So left hand limit is minus 1. So limit won't exist right here. So here I can write from the graph fx limit x tends to 4 negative. I mean left hand limit. This is 4 negative means left hand limit I am finding, which is minus 1. And fx limit x tends to 4 positive, just greater than 4, which is plus 1. So what I have learned here, left hand limit does not equal to right hand limit. So limit does not exist. Does not exist. I hope you understood why limit won't exist in this question, right? Now again we can learn this like left hand limit at x equals 4. Okay, then I will write f of x limit x tends to 4 negative. Okay, then here I will write limit x tends to 4 negative. But what is fx when x is less than 4? 4 negative means less than 4. So less than 4. What is the function? Function is constant, that is minus 1. So minus 1 will be here. Understood? And then I have to put minus 4 here. But since it is a constant function, so you will write only minus 1. You cannot change minus 1 to something else because this is constant. You cannot put x minus x4. You cannot put anywhere. So this is minus 1 left hand limit. Now right hand limit at x equals 4. Then fx limit x tends to 4 positive. Then limit x tends to 4 positive. Now what is function? When x is greater than 4. X is greater than 4, then function is plus 1. So I have to write plus 1 here. Since there is no x, so it is constant, it would be constant, so you will get again plus 1. So left hand limit minus 1, right hand limit plus 1, again left hand right hand does not equal, so limit does not exist. So this is formal way to present, like in board exams. Now let us understand limits concept with the help of one more example. fx is 1 plus x square, condition is 0 to 1. At 0 we have equality, and 2 minus x when x is greater than 1. Okay, find fx limit x tends to 1. It means we need to find limiting value of fx when x is 1. Then what is the meaning we have to understand first is, question is fx limit x tends to 1. So this time it is not mentioned, we need to find the left hand limit or right hand limit. Whenever this is given fx when x tends to 1, it means inside two informations are hidden. Two informations are hidden. F of x limit x tends to 1 negative, and f of x limit x tends to 1 positive. It means when x tends to 1, then 1 negative, 1 positive, we have to find and we have to check whether these two are same. When these two are same, then we will say, yeah, limit will exist, and whatever the value you will get, that would be your answer. Okay, so it means we need to find left hand limit as well as right hand limit, and we have to check when these two are same, then we will get this answer. Okay, if you want to understand as a theory, then it will be like this: f of x, limit x tends to a, it means f of x, limit x tends to a negative, f of x, limit x tends to a positive. Okay, and these two must be same. So this box is very important. When fx limit x tends to a, what is the meaning? Fx limit x tends to a negative or fx limit x tends to a positive. So understand and remember this concept while finding limit. Now we need to find left hand limit as well as right hand limit. So let us understand. Left hand limit at x equal to a. So f of x, limit x tends to 1 negative, then limit x tends to 1 negative, and function we have to decide. When 1 negative means x less than 1, right? 1 negative, left of 1. So x less than 1, which function we have to use? This one or this one? This one, this function we have to use. This is 1 plus x square. Now this is 1, and 1 negative means what limiting value you have to put 1 here. So this is 1 square. So 1 plus 1, which is 2, we got. Okay, so left hand limit we got 2. Then right hand limit at x equals 1. Then f of x, limit x tends to 1 positive. So limit x tends to 1 positive. And right now, 1 positive means x greater than 1. When x is greater than 1, then which function we have to use? X greater than 1, 2 minus x. So 2 minus x I have to write. Then I will write 2 minus x is about to 1, so this is 2 minus 1, which is 1. 2 minus 1 is 1. So what I got? I got left hand limit 2 and right hand limit 1. So left hand limit does not equal to right hand limit, I found. Left hand limit is 2, right hand limit is 1, so these two are not same. When left hand does not equal to right hand, it means so limit won't exist. So question is fx, limit x tends to 1, then you will write does not exist. Okay, does not exist. Answer would be does not exist. Now we can understand this by another way of writing. Another left hand limit at x equal to 1 was f of, at x equal to a, f of a minus h in the definitions. So f of 1 minus h, when limit h tends to 0, right? 1 minus h, when h tends to 0. So this time you will write limit h tends to 0. Now f of 1 minus h, which function you have to take? 1 minus h, this function you have to take. So you will write 1 plus, and this is 1 minus h, so this would be 1 minus h whole square, and you have to put 0 here. Now h is 0. So this is 1 plus 1 minus 0 whole square, which is 2. Now right hand limit at x equal to 1, that would be f of 1 plus h, limit h tends to 0. So limit h tends to 0. Now f of 1 plus h, by the way, right hand limit x greater than 1. So I have to take this function 2 minus x. So this is 2 minus, and x will be replaced by 1 plus h. So this is 2 minus 1 plus h. So h is 0. So this is 2 minus 1, which is 1. So again, left hand limit does not equal to right hand limit, and limit is also same. Previously also it was 2 and 1. So this is another way to write. I have introduced this concept which I had explained earlier. F of a minus h, limit h tends to 0, and f of a plus h, limit h tends to 0, right? So this method I have applied. Now same question we can understand by graph also. If we graph for this function, so x is 0 to 1, so this is 0, this is 1, and x greater than 1. Okay, so x is 0, when you put x equal to 0 here, then you will get 1. So x is 0, then 1, so this is 1. But 1 you will get because you can substitute 0 here. Okay? And when x is approaching to 1, then it will be 1 plus 1, 2. So for example, 2 is here. So you will get this one, this graph, but it will be open. It won't be filled because you cannot put x equal to 1 here. So 1 plus 1, it would be, and this is a parabolic graph. It's a parabolic graph, quadratic graph, so it won't be a straight line. It would be like this. This kind of graph it is, parabolic graph. So we got this graph from 0 to 1. Okay. Now when x is just greater than 1, then what is that? 0 to 1 like this graph, and x is just greater than 1, then I have 2 minus x. By the way, put x equal to 1 here, 2 minus 1 is 1. So 1 means this value you got. Okay? Now when you put x greater than 1, then which kind of graph you will get? So x greater than 1, it means you can put 2, 2 minus 2 is 0. So this graph you will get, a straight line, right? This is already we know y equal to 2 minus x is a straight line graph. So this is the graph we got for this function. Now at x equal to 1, what you are observing, less than 1, x less than 1, this value you have. Okay, this is actually a 1. So x less than 1, then you have this value 2. And when x greater than 1, just greater than 1, then you got this value. So again, left hand limit is 2, right hand limit is 1. So again, left hand and right hand is not equal, so fx, and limit x tends to 1 does not exist. So I hope you guys understood this concept. If you did not understand, then you can revise once more and let me know whether you understood or not. Thank you very much.